Hi, everyone. Welcome. My name is Aaron Smith. I'm the CEO of the Energy and Environmental Building Alliance, and we're really happy to welcome you to today's EEBA webinar series. We've got Joseph Hillenmeyer joining us from April Air. Joseph is the channel marketing manager for the residential new construction business. And I couldn't be happier to have them as a sustaining sponsor of EEBA. And, the time has come for indoor air quality. I think that today's conversation around three's a crowd. I was saying three's company as we were getting ready for today, but turns out three's a crowd. But talking about energy efficiency, humidity, and ventilation, specifically today, we'll talk about humid climate zones. But I think we want to answer a lot of your questions. And at the end, I think we'll finish up with a kind of a segment where what could I do right now in my own home? So some of you that are viewing, we all live somewhere. What changes can I make? What products are available to help IAQ in my house today? So with that, standard rules apply. We have a Q&A section at the bottom. I'll be curating the questions and then asking them to Joseph throughout today's presentation. But please enter your questions. We'd love to hear from you. You can chat with us in the chat section as well. And we will post this up on the EEBA Learning Center at the close of today's presentation. So Joseph, welcome. Great to see you.
Thank you, Aaron. Excited to be here. I'm excited to talk about heat and humidity because I'm up here in the tundra, as are you, where it's quite cold and dry. So
we're having a heat wave for everybody on the call. We're
yeah, it's like 20 today.
Yeah, it's like 16 here. People are out in shorts. So
all right, so we'll talk and its relationship with energy efficiency and ventilation. And as Aaron said, we're going to focus somewhat specifically on zones 1, 2, and 3. But as I'll mention again later, if you don't build in those zones, if you don't live in those zones, 90% of what you hear in here is still going to be pertinent. These are all about the laws of physics and the rules of humidity, so they apply in some degree everywhere. So we'll go over a few recommended solutions. We'll talk about some of the other variables. And again, this presentation.
Just for you, we have some audience members joining us from Tampa Bay, and they're already mocking us out because they have the air conditioning on down there.
Already?
Yeah, and they're saying something about Champa Bay.
I don't know.
The best thing that happened in Tampa Bay is Tom Brady going down there.
It appears that way so far. Yeah.
All right. Sorry about that.
The first year. So for those Tampa Bay folks, again, going to be very up your alley. But as Aaron said, at the end of this, we'll talk a little bit about air quality in general. We're kind of going to talk mostly about dehumidification today. But if you have questions about any of the attributes of air quality, purity, freshness, humidification, dehumidification, feel free to ask those as well. So this first slide here, this is an image from Jacob Raskussen's book, Understanding Energy and Moisture in High Performance House Design. And it's a great book, by the way. And it's a great reminder, I think, of all the things we do to manage moisture in all of its forms and how important that is in the building process. And I've kind of included it here for two reasons. I want to show that, that we do a lot of things with the building envelope to keep moisture out. A well-designed enclosure, as he says here, keeps water out, controls airflow in and out of the building, keeps heat in or out, and allows or controls vapor migration. So
Joseph, Joseph, what's OVE just for the audience?
Oh, I believe it's overvalued engineering. Is that what they call it?
Okay.
So basically, overconstructed, I suppose would be another way to put it. Probably not the greatest example, but anyway, one of many ways that we can really, that we're overbuilding these envelopes specifically to manage energy efficiency and also to control moisture. So, all in all, this is a good thing, what you're seeing here, right? I mean, we did these things so that we could meet energy goals, so that we could have better homes. And then we go and we punch a hole in it. And that's where this relationship, gets kind of gets a little rocky. And when it comes to ventilation, that could start as simple as a loose window, a loose envelope, an open window. I mean, that's still, as long as you're bringing air into the house, that's technically ventilation, all the way up to things that are far more controlled and efficient, where we're bringing air in from a known source and perhaps where we're conditioning it to some extent. So And, obviously over the years, we've moved much, much closer to, that type of ventilation. I think the idea of just opening a window to get air in the house is something that you don't do a whole lot. You certainly don't do it in Tampa Bay, and you wouldn't do it here in Wisconsin right now. So, but we need fresh air in the house, even when the air outside has attributes about it that wouldn't seem preferable. And with that, we've managed to design pretty well around this. We have a building envelope that's tight, that can help keep moisture out, that can help uh, manage heat and air conditioning and do it efficiently. And then we have ventilation solutions that work with that. And we haven't perfected it yet. I'm not saying that as an industry, but we're certainly getting much better at achieving this balance so that we don't have to choose between energy goals or health. We can deliver on both of those. However, there are certain seasons and certain climate zones where the obstacles we do face are, considerably magnified. And that's because of this third wheel humidity. And we'll talk real quick about absolute versus relative humidity, because it's really important to understand in the understanding of why you need to choose the solution that you do. And it's also just interesting for those of you that aren't familiar with it. There's a lot going on with air temperature and humidity, air and water, an interesting relationship. So for absolute humidity, the example we have here is, we'll say that this red square is some air that's at 80 degrees Fahrenheit. And it has an absolute humidity of 80 grains. That number would be taken from a psychometric chart, by the way. I believe 80 is pretty close to what it would be. It might be a little bit different, but we're more or less there. And that would give you a relative humidity of 50%. So again, these numbers come from the psychometric chart. We're just using them as kind of a benchmark here. If you reduced the absolute humidity of that air, so if what you did was remove moisture from the air, down to relative humidity of 25%. You haven't changed the temperature, but you have removed moisture, so you've lowered the relative humidity. That's because absolute humidity is the actual amount of water vapor that's present in the air, and it's expressed in grains. On the other side there, what we're showing is that you can also manipulate RH with temperature. However, because you're not changing the absolute humidity, what you're actually doing is changing how much moisture that air can hold. So if you look at that graphic there, imagine that the blue dot is absolute humidity and the yellow dot is the amount of moisture that air has room to hold. As that temperature goes up, the amount of moisture that it can hold goes up as well. But the RH does not go up because we haven't added any moisture to the air. And as I said, talking about indoor air quality a little bit more holistically, this here on the right is something we obviously experience much more up here in these colder climates, because we bring that air in and we heat it and we drop that relative humidity way down. Not a problem that you guys probably have very often down in zones 1, 2, and 3, but it just one of the ways that humidity affects us on the other end of the scale as well. Relative humidity, that's really the number that you're most probably familiar with in your home. Relative humidity is how we tend to it's how we measure humidity in the home. And it's a percent of the water vapor that's in the air compared to the actual amount that it can hold. And if you have a humidistat in your home or a humidifier in your home, when you set it for how much humidity you want, you're doing that on relative humidity. So again, just quick recap, relative humidity is the amount of water vapor in the air compared to the amount of water vapor that the air can hold. Warmer air temperature is the more water vapor it can hold, and the cooler the air, the less water vapor it can hold. That's as we saw on the right side of that graphic. Changing temperature only changes the relative amount of water vapor in the air, but not the actual amount of water vapor. That's kind of the main takeaway from all of this. So, that's our energy efficiency side, our humidity side. What drives our ventilation choice? Well, I think we know, certainly it starts with codes and standards. They're part of what drives this. I think we can probably all agree that, codes and standards certainly don't ensure a healthy home, or maybe even necessarily an efficient one, but they're our starting point for this. But to really deliver on these promises, we need to build to geography and envelope. And one thing I'll get into significantly is we need to build to homeowner habits, because people are going to live in these homes. And that's an important consideration when you're designing to manage for humidity. So we're going to start, the first thing, we would want to look at is what climate zone are we in? Obviously going to have a huge impact on which ventilation solution we actually choose, because of what other attributes we're going to need to manage to when we bring that air in. As I said, we're going to focus specifically today on zones 1, 2, and 3, and particularly zone 3 in these coastal areas where you're south of that warm, humid line. But if you don't build there, there'll still be plenty to learn. So do not log off, please. So humid climate zones. We April did a case study a couple of years ago down in the Florida area where we measured how much moisture we were bringing into the air when we ventilated, and we came to the conclusion that ventilated air could bring in, depending on the conditions outside, obviously somewhere between 60 and 100 pints of moisture per day into the home in those climate zones. So that is a lot of moisture to bring into the home when you're ventilating, clearly. And even if the air conditioner could handle that latent load when it's running, it probably couldn't, but even if it could, it's not going to be able to do it when it's not running. And the reason that's important is that in these climate zones, we have shoulder seasons where your air conditioning is not going to be running a lot because the temperature has been milder, but the humidity is still high. So whatever latent removal you were getting from your air conditioner is now, you're not really getting any of it because it's not running long enough and it's not running often enough. So we have to mitigate that moisture in some other way. Our air conditioner will not do it. And by the way, latent loads, we have sensible and latent load. Sensible is what an air conditioner or a furnace takes care of. That's temperature. Latent load is moisture. Air conditioner can do a little bit of both, but it is designed to handle sensible load. A dehumidifier, on the other hand, removes the absolute humidity regardless of temperature by condensing the air below the dew point, and then you shed that water off. That's why we're able to remove that without doing anything to temperature. And the big takeaway you'll see from this is that a dehumidifier is a dehumidifier and an air conditioner is an air conditioner. So it's not that air conditioners aren't effective. They're effective at doing what they're supposed to do, which is manage temperature. The fact that they reduce some humidity is a great side effect, but it's not what they were designed to do. We take the hot air from them and we blow it back outside. We keep the air in with a dehumidifier. What we're trying to do is just simply remove the moisture. That is the only job that a dehumidifier has. And again, it can do it without lowering the temperature of the space. So in these climate zones, your ventilation solution really should be capable of managing both the latent load of the air in the ventilated air, but you also want to manage the load that exists in the home within the home. You haven't brought it in from outside. It's the RH that just by nature builds up in a home, even when we're not ventilating. And I'll go back to that real quick. And the reason that's, I think, so important is it can kind of be overlooked. I mean, ventilation is not the only thing that brings moisture into the home. So if the only way that we're tackling it is when we're ventilating, we're missing a huge opportunity to take care of some of that moisture. A little bit about the solution I just showed you. That's the E100V 8190FF. So this is our ventilating dehumidifier. It's a ventilator, but it has its own dehumidifier built into it. It's built off of our Energy Star series of dehumidifiers. So it can condition the air with its own condenser to remove humidity before it delivers it to the living space. Has an airflow of 165 CFM. That minimum 75 CFM you see there, again, a benchmark. That would be a variable number depending on a lot of different things as far as how much you would actually need in your particular home. But it gives you an idea that we're intentionally delivering quite a bit more than we need. And the reason for that is when we over deliver on airflow, we can choose when that ventilation occurs. We can be more selective. So there's less minutes within the hour that we're ventilating, so we can choose which of those minutes are best, which of those hours of the day are best. And that's important because it allows us to do things like piggyback off of an AC call. So if we are ventilating and the AC is running, we'll lock out that dehumidifier and let the AC do what it can with that latent load. We don't need to run two things. We'll have the dehumidifier there if we need to circulate that air and get more RH out of it later, but we can piggyback off of that call. We have temperature lockouts as well. So if it's yeah.
Yeah, can you talk about, most of us are familiar with a spot dehumidifier, mobile dehumidifier in our homes, and it's going to produce heat into the room. Does that dehumidifier system, is it going to create heat in the space? Is that exhaust to the outside? How does that function?
So there is some heat that comes off of it. I mean, that's part of dehumidifying. It's not a noticeable amount. And again, it'll be ducted. It's ducted directly into your return. And so if there's a cooling call or when you're running that fan, that will get dispersed. It wouldn't be a noticeable amount of heat.
So, and that's part of the Energy Star certification that you have on this product is when we go buy a cheap one and plug it in, that may or may not be the most efficient. Is that what I'm hearing you saying?
Yeah, and the other thing that's really important with dehumidifiers is capacity. I mean, just like any other equipment, if it's undersized, it's
Hmm.
just going to cycle and run more often. So even if it has better energy ratings, on paper, if it's running all the time, that's out the window. So these dehumidifiers that have a large capacity, this is like 100 pints. If you looked at something at a retail location, you would be closer to, maybe 50 pints per day, perhaps less than that. Yeah, that's probably not going to handle the load in most places. That's typically something you would see in a garage or a basement when you have a specific area that you want to keep dry. Now, there is a stack effect with humidity. So if you remove it in one location, I mean, to an extent, it's going to balance throughout the home. But a whole home solution that's circulating the air just like an air conditioner would is really a better way of doing it.
Yeah.
Um, so the product has an integrated damper, which will allow us to toggle between just that, whether or not we are dehumidifying ventilated air or whether or not we're dehumidifying indoor air.
Right. And with
So
that product, Joseph, you're also able to precondition outside air. So when you do ventilate, you're actually able to dehumidify that air before introducing it into the air conditioning system, right?
exactly, yeah.
Yeah.
So yep, we can piggyback off that AC call if we want to, but the whole point is that we've got this other we have this other ability to condition it. So no matter what's going on, we're never going to dump unconditioned air into the home. We're going to dehumidify it.
Great.
And the way that works is there's this 10-inch damper, which would be the normal intake for our dehumidifier. That'll still be there for when you're recirculating the air or you're conditioning the air that's in the home. But then we have the 6-inch ventilation damper, and there's two dampers there that when one's open, the other one is closed. And so when we're ventilating, we'll open up that ventilation damper. And because we've got those two dampers, that full amount of the CFM will go through the ventilation damper there. That's how we're able to get that high performance airflow. And that incoming air will be conditioned again, either with the AC if it's running or by the dehumidifier if it's not. We switch that around. We close that ventilation damper. We open the one that goes to the living space or that goes to the ductwork that goes to the living space. And now we're conditioning the air that's inside the house. Shows you what a setup like this would look like when it's installed. This is, obviously an attic installation here, installation where we've got the equipment on its end. You're pulling the air in through your fresh air intake hood out there into the 6-inch duct of the of the dampered system there. Below that, you've got a 10-inch duct. As you can see, it's going to an intake grill that's going to pull air in from within the home. And then it's all being ducted into the return. That's so that we can take advantage of those AC calls when they happen. So let's say we have a call for ventilation and there's not a call for AC. So temperature's okay. It's time to ventilate. We're bringing in some humid air from outside. The dehumidifier will engage its coil and it will remove moisture from that air before it delivers it to the rest of the living space. And by the way, it will also, as we can talk about later, some of the other IQ solutions. Another benefit here, reducting into the return like that, we're not only conditioning it for humidity, but this way you can put it through the filtration system that you have as well and, condition it for pollen and other types of pollution that you could also bring into your home when ventilating. For the most part, outdoor air is cleaner than indoor air because of its lower concentrations, but you're still bringing things in all the time that you wouldn't want to bring in. So filtering it is an important part of this as well. If there is an AC call, we'll still use the ventilating motor. We'll still use the ventilator's motor to bring that air in, but then we'll use the air conditioner to start conditioning that air. So again, we're piggybacking when we can. We're using the available equipment to do the job. Now we get to that scenario where indoor RH is above the set point, but there is not a call for cooling and there is not a call for ventilation. We still need to do something about that indoor RH. We don't want to wait until one of those other things happens. So by setting an RH set point on the dehumidifier, when it recognizes that RH is above the level that we want it to, it will again close that damper, open the other one. It'll circulate that indoor air, remove moisture from it, and introduce it back to the living space. So you'll be able to keep your RH within acceptable ranges all the time, regardless of whether or not you're ventilating, air conditioning, or doing neither. Some other variables, the reason that purple line, that third thing is so important is that, each home can be designed a lot of different ways, identical design principles. We can manage to a lot of the same variables, but we can't manage the variable that we don't know. And that's how the people that buy the home are going to live in it. And humidity, just like every other attribute of indoor air quality, is just a side effect of living in a home. Cooking, cleaning, bathing, laundry, all these things impact IAQ, and they also all impact humidity. Now, I'm not going to say that in zones 1, 2, and 3, more of your humidity is coming from within the home than outside when you're ventilating. That's probably going to certainly be the primary source of RH, but RH of humidity, but humidity in the home is still on the rise from the things that the homeowners are doing in there. And what we found is how important that is to health and comfort. There's a relationship between humidity and temperature that have a lot to do with how we feel at a particular temperature. Yeah, again, I mean, down in Florida, it's not just hot, but it's hot and humid. In Arizona, it might be hot, but it's dry. We feel different in those two climates, even if the temperature is the same. Again, that holds true when we're in our home. So we need to stay in that range where we've got acceptable humidity along with our temperature. The health aspects of it revolve around lots of different issues with your lungs. Asthma, allergies are all aggravated when you have more humid air, make it more difficult for those people to breathe. There's preservation aspects of the home as well. I mean, obviously physical water wreaks havoc on a home. We all know that. Unfortunately, we're seeing that in Texas right now with all the freezing that went on down there. But water vapor in the air does as well, as we have cooling and drying cycles and we pull moisture in and out of wood and trim and floors. We really do damage to those structures and the things we bring in the house with us, musical instruments, stuff like that. So to protect those things, controlling humidity is extremely important. And you need to build the home for everybody. So while some people may be able to tolerate high humidity, maybe they've lived in it all their life, it just doesn't bother them all that much. It could be absolutely unbearable to other people that have a different comfort level or, have some type of a health issue that's aggravated by high humidity.
And Joseph, are you going to talk about kind of what the zone is that you want to keep that house in later on?
I will. And
Okay, great.
There's actually, there's a slide I should have put in here that I did not, that has the ash rate chart. We can, maybe we can include that in the recording, where the zone, and the reason I'm glad you brought that up is, there's a high and a low zone for it, right?
Right.
So, we want to be, roughly within between 30 and 60, probably closer to between 40 and 50, honestly,
Right.
around the 50% mark. And, in some climates, that would require managing both times of the year, adding at one point and
Yeah.
removing at another. So yeah, very important that both sides of that, where that zone is.
Mhm.
Something else I just kind of wanted to approach was, well, what about ERVs in a climate zone like this? And I'm certainly not going to knock on ERVs. ERVs are great. They're a great solution, especially for energy goals. But in these climate zones, we certainly wouldn't recommend them as the first choice, because much like air conditioners, they're simply not dehumidifiers. That's not what they do by nature. They're only going to be having an impact on that humidity when they're ventilating, and that's going to be hamstrung by what the rates of humidity are inside and outside of the house. So for example, we talked about that, potential to have 105 pints of moisture being brought into the home when you're ventilating. Even if a great ERV was able to cut that in half, you're still talking about 50 pints of moisture being added to the home. Again, that's a lot. You have to mitigate that in some way. Now, as we get out of these climate zones, does that change a little bit? Yeah, the solutions you could use would be different because you have different conditions outside. That's why we always say that we've got a solution for every application. It's really, there's not a one size fits all with humidity control or ventilation. I mean, it really requires a deep understanding of the environment around that home and in that home to get the right solution. And furthermore, what the ERV can't help us with is, when we're trying to remember that we've got that RH that is coming in the home just from living in the home. We didn't bring it in when we were ventilating. It arose when it was in there. It made humid conditions. There's no ventilation call, no AC call. We still need to get rid of that moisture. Best way to do that's going to be to use the piece of equipment that was designed to do that, which is a dehumidifier. So, a dual purpose device like the E100V 8190FF, you've got a system that can manage humidity no matter where it originates, can condition that air before it delivers it to the living space and help you manage the problems that come with high humidity. So, as I said, I think what we're really talking about here is using the right solution to the problem. You can pound a nail in with either one of these objects, but you can do it much more efficiently and much more effectively if you use the hammer. And, in this case, the dehumidifier is the hammer. You want to use the thing that was absolutely designed to get this job done as quickly and as efficiently as possible. And some of the other solutions that are out there just would not do it. You need that high airflow and you need that ability to condition the air before you deliver it to the space. And a couple other points on why I think dehumidification matters is, we don't just want these homes, I believe, to be healthy and efficient, until the warranty runs out or after the first year. We want homes with good bones and good lungs. And, having a system in place to manage that excess humidity for the times when it does get high, maybe that's far out from the time that the people purchase the home, but it's still going to be important. Why should they have to go buy a dehumidifier from a retail environment later if the home would be better served by having one now? So I think it just goes to the idea of, building a home with the occupant's health in mind from the very beginning. And we have to admit that these homes that, look good on paper, they have to encounter that random variable. So, we need to prepare for maybe humidity that we don't think is going to be there now, but could be there when somebody starts living in the home. And so, lastly, the relationship between energy efficiency and ventilated air is already kind of rocky. It's already delicate. Let's let it be and not bring in that third wheel of humidity. Control that humidity separately, or control it at the same time, but with a solution that's meant to do it. We can keep it from popping up and interfering with our health and energy goals. So I went through that kind of fast, but I'm happy to take questions. You can also, if you want to learn more about the specific product I talked about, visit us at aprilair.com, healthybuilders/8190ff. You can also call or text me if you'd like to get in touch with anybody else. If you got a more technical question that I can't answer, I'm certainly happy to put you in touch with some of the smarter people at my company that can. Shoot me an email if you have any questions. You can also connect with me on LinkedIn. And with that, I'll field some questions now. Aaron, I can talk a little bit more about other attributes of indoor air quality if you'd like as well.
Yeah, well, a couple quick questions.
Yep.
If we dehumidify, aren't we naturally going to be comfortable at a higher set point on the air conditioner?
Yeah, and that's where that relationship between comfort and temperature comes in. You could technically, you would probably be turning your thermostat up a little bit. 74 and 50% humidity is much different than 74 and 80% humidity. So even though you're running that dehumidifier, which, obviously is going to have energy associated with it, you're making some of that up by changing the temperature and the amount of work that you're asking the air conditioner to do, even on the sensible load, because you don't need it to remove as much heat because you're comfortable at that higher temperature. So,
Joseph, have you done any studies on that? I have friends in Florida who are, pay $600 a month for their air conditioning bill, but the adding in the dehumidification and raising that set point, what does that offset look like?
yeah. Don't have a core number on it, I guess would be my answer.
Yeah.
It's certainly something we've looked into. Believe me, it would be great if we could get that, energy payback of it. Part of it is you're talking about comfort, which is subjective. So, would every homeowner see an energy benefit to that? Maybe not. I know when I travel to Houston or Florida, I walk into a building and I can't believe the climate. I'm just not comfortable, air conditioning air that's 90% humidity down to 62 degrees, but apparently some people that doesn't bother them. So I think anytime you're dealing with, something like comfort, you want to give them all the solutions they can, but you need to let them, manage that to some point. So, I think that's something we'll continue to work on, but I can't answer right now exactly, at what point you get an energy payback if you're dehumidifying.
Yeah. Joseph, do we use, our commercially available thermostats geared to control the dehumidifier, or are you putting a separate humidistat in to run that system?
This has an onboard the ventilation control and humidistat are built into it, but the dehumidifier, those attributes of it could also be controlled by an Aprilair thermostat. Those communicate with our dehumidifiers.
Okay. And can you set that system up to like an ASHRAE 55 air, or I guess it would be actually 62.2.
62.2. Yes. Yeah. When set up correctly, it will ventilate to ASHRAE 62.2. That's in the setup options. Obviously, that's, normally what you're going to want to do,
Yeah.
is hit that standard. So yes, it's designed to that when you set up that airflow, that's what you're going for, is 62.2.
Yeah,
So
that's
you'll meet
great.
those codes and standards.
Yeah, that's incredible in and of itself. In homes with multiple air handling units, would there also be multiple dehumidification systems? Or would you do your air intake, go to your DH, then go to multiple AHUs?
You would, that's probably one I'll hand to more technical people, but I would say you're still, it depend on how much air you needed to bring in, and what's the square footage of that home. Is it two systems for a zoned reason, or is it two systems because of the size of it? This dehumidifier does get larger than what's on here, so you could actually scale up the dehumidifier to one that is able to remove more moisture. If you had, technically, if you were pulling in ventilated air into both of those systems, then you'd need to have the dehumidifier on each, because either one of them could be introducing that, stagnant air. If you were just
Right.
pulling it in on the one, you could maybe overcompensate a little with the dehumidifier on just that one system, and that's how your ventilated air comes in. But
I mean, I would think you'd have one penetration for fresh air in the home. You'd bring that into
yeah,
D.
and yeah, and in that case, again, I mentioned the stack effect. That single dehumidifier is going to work as well. It's going to pull that out in that area. Again, anytime we're talking about homes, nothing is 100% in every scenario, but
Right.
depending on the reason that you have those two systems or the size of the home, it might be something you can still solve with just one product.
Yeah. Joseph, if you have an energy recovery ventilator in zone 1, 2, 3, where would you put that in the installation? Would you put that on the inboard side of the dehumidification or on the outboard side?
So you're talking about using an ERV and the dehumidifier?
Yeah,
Either
or is your recommendation you don't need that in climate zone 1, 2, and 3?
I don't think you would need that. You would be relying just on the dehumidifier to handle that. It'll do that every time. That would be a little bit overkill. Yes, you would get. The answer would be no, you wouldn't want to do it.
Yeah.
If you're worried about the humidity, stick with the solution that is made to
Yeah.
handle the humidity and the
No,
ventilation.
I mean, I like what you're saying there, is that a lot of us that have lived in humid, we tend to, you think you're going to use your air conditioner to get rid of humidity. And it's
Yeah,
not great. It's not a
yeah,
great
and
solution for
and
it.
and you end up, just overcooling the home. And again, you're once again, you're not doing any favors to energy goals
Right.
either. I mean, this whole conversation is we're trying to balance, energy and health here. And it unfortunately sometimes it just takes a little bit more consideration, I think, than we probably like it to. But
Right. Joseph, what about in the case with a heat pump system in the home? Do you just do a separate fresh air system with the dehumidification on it that runs independently of that? So you're bringing in fresh air that's dehumidified into the home. The heat pump is dealing with heating or cooling load, is dealing with latent load, latent load. You're dealing with sensible load, right?
yeah, so you could still duct it to the return of that system if you wanted
Okay.
to, because again, it's gonna be conditioning that air and it'll deliver it to the living space. If you had like a situation where you're using mini splits or something, then you'd
Right.
want it, obviously dedicated, because you don't have any ductwork. So.
Right. Yeah, I was kind of thinking of the mini split situation where
Yeah,
you got
yeah, you'd have that intake there, and then you would just have it on when it exhausts there, instead of going into the return, just have that go back into the living space, and that would take care of your humidification issues. When you needed to recirculate the air as opposed to pull it in. So.
great. Well, I have a couple questions, and I'll encourage the audience, if you want to continue to put questions in while I ask a couple questions, please do, and we'll get to those. But I think I want to selfishly bring it to where Joseph and I live, which is kind of zone 5. And we have a case where in the wintertime we need to humidify, and in the summertime we need to dehumidify. Can you just talk about the different, and I'm sure there are times when everyone needs to humidify. Um, as well. But can you talk about that balance of humidification, dehumidification? Maybe we don't see that often needed in 1, 2, and 3, but the rest of the world
Yeah,
in
the
shoulder
rest
seasons.
yeah, the rest of the country, it's going to pop up. We certainly can't compete with Florida right now on temperature, but there are times here, at the bottom of top of zone 5, kind of where I am.
Yeah,
Um, we have hot, humid summers. I mean, it's
yeah,
the RH in my house right now, if I didn't have a humidifier going, could easily be 10 or 20%. In the summer, if I didn't have a dehumidifier and an air conditioner, it could easily be 70 or 80. That is a
right.
huge swing in moisture. Um, and again, a great way to look at it, if you're a musician, is just look at what happens to instruments. I mean, if you're trying to keep a piano tuned in an environment like this is almost impossible, as it would be with guitars. I mean, you can have, the effect that moisture has on wood is really unbelievable.
Yeah.
And in these climate zones, in addition to what you want to do for your health, obviously. So right now we want to be humidifying, again, for those comfort reasons we talked about. We've got that ASHRAE scale. We want to stay in that zone where we're comfortable.
Yeah, and
But there's
again, for the audience, it's 30 to 60, 40 to 50, ideally, right?
Yeah,
Yeah.
yeah. And again, we'll try and include what I call the ASHRAE chart in there. When we put the recording up, it's a great example of where that zone is and how you need to manage to it on both sides. And the other interesting part about it is, it's not just the comfort zone. There's kind of an incredible thing that happens where all of the bad things don't like that zone.
Right.
So dust mites don't uh,
Well, tell us
proliferate in that
about,
zone.
we're all still in the midst of this pandemic, and I mean, COVID does not like the zone either, does it?
No, yeah, no viruses do, and that's why we heard, early on, was the summer going to drive this down? Uh, Obviously part of that was, okay, we'll be outside, we won't be indoors. But a big part of it was, is humidity going to have the impact on this that it has on most viruses,
Mhm.
which is where they end up, attaching to those heavier moisture particles, and they just drop down. Viruses aren't as infective in humidified air.
Mhm.
So, it's extremely important. We've heard a lot about ventilation. Thankfully, during the pandemic, ventilation and air purity have definitely gotten, some due press, but humidity is a part of it too. And, I don't think they don't quite have the studies yet to where they're comfortable saying, humidity definitely lowers it by X amount, but we can talk in generalities about how we know viruses respond, and how especially airborne viruses respond to air that's well humidified. And it's that they're less infective. So, you know, again, staying around that 50% mark, or a little bit lower in the winter, it's going to help keep the family safer from that point of view. Additionally, our bodies, the mucous membranes, your nose, your throat, um, you know, that excess moisture helps them operate the way that they're supposed to. Their whole purpose is to help keep some of these things, from entering your lungs. So, when your body's properly humidified,
Mhm.
you'll do a much better job. So
Yeah, no, that's a great analogy. I mean, it's so important to keep in that range, and I think that's the big thing that we're learning. I had a quick question that came up. Will a ductless mini split system require separate ductwork for the dehumidifier system to serve the entire house?
let me follow up on that one.
I mean, I would say from the builder
I,
perspective, my answer would be, well, it depends on the house style, right? And it
yeah,
depends, you got to think about that fresh air, or the return. Where's the return? Is it going to draw from enough? But I think if I was building the house, I would put ductwork in with returns in, so I was ventilating at least the bedroom areas, maybe a main living area. I try to pull as much air through that system as possible and
yeah.
dehumidify that air. But we'll get back to you. That was from
Yeah,
Steve.
I'll get a specific answer on that, but
Yeah,
I think the way you're going with it is probably how it would be done.
yeah, I mean, it makes sense. Uh, One question I have, and I've learned a ton from getting a chance to spend time with April Air and see some of their great new products. But what can we all do right now? And it probably, and maybe you want to break the conversation up between climate zone 1, 2, and I guess I'm in 6. I forgot I was in 6, but I
Yeah,
live in
you're
six.
Minneapolis, right? I guess you're
My,
six.
yeah, my inside humidity right now is 32%. And I have a April Air whole house dehumidifier or humidifier. I have a dehumidifier for summertime. But there are great things. We've all shifted from our office building to working out of, or not all of us, but working from our home. Our homes aren't always set up to do ASHRAE 62.2 and deliver the right humidity level. What are the things that you're thinking about at April Air that people can maybe go out and purchase right now around air purification, around dehumidification, around humidification? Can you give us a quick,
Yeah,
what do you recommend to your friends right now?
I think the number one choice you would want to have in any home, just because it's if you have a forced air system, let me say that first of all, would be MERV 13 whole house filtration. Just be, that's literally removing these damaging particulate that are in the air that we know impact health, not just in the short term, but in the long term. I mean, these are things that are in the air that are, there is no question that they're bad for us. And if we don't filter them with the systems in the home, then we're filtering them with our lungs, and that's where they start to cause problems.
Right.
So,
And
I really think,
that's going to take out PM 2.5
yep,
level. I mean,
exactly.
is that a HEPA level or almost a HEPA level of filtration?
Yeah, I guess you could say it's HEPA like. They're actually got MERV 13 is minimum efficiency reporting value. It's a little bit different
Okay.
rating or scale. And and by the way, if you currently have a furnace and you're looking for a different filter, when you go to like a Home Depot or something to
Yeah.
replace that, you might see a different scale there too as well. So again, that's something that hopefully one day all the industries can get a little bit more
Yeah.
aligned on. But we're going to say MERV 13, figure out how maybe that translates if you have something different, but you get at least that in your home, and our installed systems are very common. They use there's a cabinet, and then different filters can go in there. And you can go up to MERV 16, you can go down as well. But MERV 13, when it comes to PM 2.5, the one we're really worried about, it does the trick. And, technology's gotten to the point where we can keep the pressure drops where they need to be so that you're not doing any damage, to energy goals or your system
Yeah.
in general.
And just a key point on that, like, you have to be careful. You can't always take your flat media filter out, drop a MERV 16 in, and hope for the best. If you have,
Yeah.
you may create enough air drop that air conditioner or furnace then doesn't operate correctly. You might be better suited to getting an air purifier from April Air, putting that in line. That MERV 13 or 16 is going to be a pleated, deeper media that's going to allow proper airflow across that system. Is that right, Joseph?
Yeah, that's right. And, sometimes there's people hear thicker media and they think that, well, is there more pressure because of that? No, I mean, it's pleated. And when you add up that surface area, you have much more of it. The more surface area it has to press against, actually, the less pressure there is, and that's a good point. I mean, you could, there are 1-inch solutions that offer, a higher MERV value, but a no contractor is going to be happy if he walks into your house and sees it, because he's going to know what's happening to that system you've practically stuffed a piece of cardboard in there at this point, right? There's not enough air going through there. So yeah, definitely when we're talking about high efficiency filtration, we absolutely, we mean, an aftermarket April Air filter, one that's installed, not just replacing that 1-inch that came with your system.
And Joseph, if our audience can't deploy that, or if you can't get an installer in to deploy that, you have mobile systems as well, do you not?
Yeah, we have portable air purifiers also. And even with those, you can get enough square footage where, if you put it in a space where you spend a lot of time. And sometimes even if you have whole home, we have people who they still use the portable one because they want it in a nursery, or they want it in a bedroom, or maybe they've got a room with a fireplace or something like that. So, you can use it as kind of an auxiliary. But, the great, as April Air, we always used to we kind of sold against portables for a long time, and now we've embraced them because they're a part of the equation.
Right.
You don't only deserve healthy air if you live in a single family home with a forced air system. If you're in an apartment a condo, someplace where maybe you don't, maybe not a condo, but yeah, somewhere where you don't have the ability to
Right, you don't
improve the
control it.
mechanical system. Yeah, you don't own it.
Yeah.
You still need to have access to those solutions. So both humidification and air purification, are issues that can be handled with portable units. A little less efficient. You might need more of them if you're trying to get a whole home impact on them. But if you're in a smaller space, just again, when you're looking for those solutions, make sure the square footage that you want them to treat is there, so that you're
Right.
not overusing them. Again, with dehumidifiers, those are sometimes called portable as well. But really, that's sort of a different story. They're more portable in that they're smaller, but because you don't have that capacity, we wouldn't really ever recommend those. If you've got the opportunity, if you need to manage the humidity in the whole house, get a whole house dehumidifier, because you don't have that capacity, you're definitely doing issues. But you don't need ducting to use a whole house humidifier. So you can get a high capacity humidifier and just run it in the space, and you'll still get that benefit. So.
Right. Great. And then talk to us about, for those of us up north with our inside humidity currently at 32%, what should we be looking at putting in to get that humidity up to that 40-50% level?
So there's a couple different ways to add humidity to the home. If you have a forced air system, that's going to be with evaporative, which is, I believe that's, I think you said you have an evaporative one,
Yeah.
right? So that's where you've got like you've seen it, you got like a wick that gets water on it, and the hot air blows over it, and then it turns that into vapor and disperses it throughout the house. Tried and true method, been around for 70 plus years. Air invented one of the first whole home humidifiers. And if you come up north, you go into anyone's basement and you see that box on the plenum there. But we're getting to the point where we're starting to be able to see that take on another climate zones where maybe they don't have quite the degree of dry air problems that we have, but they're still not in that healthy zone. So
Right.
they need to add to that. I mean, if you're in zone 4, you're probably still going to want to consider humidification. Another place where it's getting
And
interesting.
by the way, I just want to point out for the audience that my April air humidifier works awesome, but I have a 1962 Cape Cod and it's just leaky. So it's not that I'm not creating enough humidity, it's that it's dispersing.
It's not staying in there.
It's
Yeah.
not staying in there. Yeah.
And good segue. So the other solutions that we have are steam, and that would be
Yeah.
when they would be used. So if you have a leakier envelope, you would go to steam. And that's just simply because the capacity is
Right.
greater.
Right.
So, we can either do much larger homes with steam units, or we can also do homes with, where the envelope is just allowing too much of that to escape or
Mhm.
dry the air out. So, really a solution for every application. The other nice thing about steam, and we talked about people being used to the climate conditions that they live in. It's kind of a hard sell, but if you're out in the arid West, you should be humidifying during the warm months. I mean, dry air is dry air regardless of the temperature that surrounds it. And as I said, it's kind of one of those situations where I think, to an extent, people in those areas have kind of gotten used to it. But
Mhm.
it's truly the kind of cliched, but the feeling is believing. I mean, once you've been in an environment where those things are correct, I think it'd be hard to go back. So it's great that we're able to deliver humidity, again, in areas where they don't have a heating call, because just because you're not heating doesn't mean the air is not dry.
Great. Maybe a final question. What are you thinking about next? What is on the roadmap for residential homes? What are you thinking about around smart homes, about just maybe your thoughts?
I think certainly we need to continue to embrace smart home with IAQ, because we obviously have the pandemic that's driven a lot of the IAQ awareness right now. There's no question about that. But I think the reason it started right after the smart home trend, kind of peaked or simultaneously, was what gave us an insight as to what these mechanical systems can really do. I mean, when we were finally seeing numbers from them, hey, my humidity's dropping, I can actually do something about it, as opposed to just every now and then you walked by that humidistat and maybe adjusted it. So I think smart home is going to help healthy home, because it's just making us aware. I mean, we've got solutions now that are almost like a Fitbit for your home's health. You can monitor your indoor air quality wherever you are. I think the next big part, of smart home as it relates to IAQ, and things, certainly stuff that's on our roadmap is, how do we get sensors that read
Mhm.
the that read the correct information and know how to interpret it to control a mechanical system, in the way that it needs to be moved. Because it's one thing to just say, well, I detected this, right? Something spiked, something's going on, but what was it that
Mhm.
spiked? Did somebody just breathe too close,
Yeah.
to that sensor? So I think that'll be the next big thing that everyone in the IAQ industry needs to figure out, is how do we tie these sensors a little bit closer to the actual systems themselves. And we'll continue to, with that, automate how healthy the home is, and where we want people to be aware of it. We certainly don't want them to have to constantly think about controlling it. I like that. I think that's another great comparison between IAQ and energy efficiency, is that when we make these promises to people before they buy these homes, we don't want them to have to move in and then constantly make an active choice for the home to be energy efficient or for it to be healthy, right? And we've already put that there. And again, smart home is one of the things that it'll allow a little bit more drivability from the consumer, but it'll also allow a little bit more automation as well. So
Fantastic. Joseph, I want to thank you so much for joining us today. This session will be posted at eeba.org on the learning management system, and we'll try to add in the chart that you talked about before as we post that up. So
great.
great.
And I'll say, if anybody else has any other questions, and no matter how technical, go ahead and shoot them to me. I'll get them to the right person. If you've got installation specific questions, anything like that, just get in contact with me and we'll put you in touch with someone for any of the IAQ needs that you have.
Awesome. Thanks, Joseph.
Thank you.
Bye.
Bye.